So can anyone tell me what is meant by the principle of the projection? Anyone? So what is the meaning of this? Kindly students, you should speak in the class. So what is the principle? What is meant by the projection? Students, can you hear me? Hello.
Yes,
Hello.
sir.
Okay. So see, projection indicates, okay, when an object, you can say this is an object. Okay, so you should have the light source, I told you. Okay, the light source, or you can mention this as the observer. Okay, the observer will be here. So if this is an object, okay, you can say the view. Okay, the view which is falling on the screen. So you can mention this as the screen. In technical term, we will call this as plane. Okay, plane. Okay, in CAD we will call that as plane. So when you're viewing the object, okay, when the view is followed on the screen, okay, that is called as the projection. Okay, so here when you see it, so this is observer. So when the observer is looking at the object, okay, so these are called as projector. I explained to you in the previous class. So these are called as projectors. So which is falling on the screen, right? So right, students.
Yes, sir.
Yes, sir.
So
Yes, sir.
when you join all the 4 points, okay. So this is called as front view, right? Front view. Okay. So this is called as projection, or it is called as plane of projection, or we can say, or the image, okay, or the mirror image, which, or you can say the shadow which is falling on the screen. Okay, so that is one point. Or you can say, okay, the view which is falling on the screen. So this is called as plane of projection. Okay, the main thing here is the elements which are required is, one is object. Okay, next is the light source, or we can say the observer, and you want the screen. Okay, or you can call that as reference plane or plane. It's called as reference plane. Okay, or it is called as plane. So be careful. You want 3 elements. One is observer, object, then the reference plane. Okay, so this is called as principle of the projection. So when you want to define this statement, it's very simple here. When an object is introduced, between a light source and a screen, okay, a picture will be cast on the screen. Okay, so this picture okay, this picture is called the projection on the screen. Okay, so what is this called, students? Can anyone tell me? So what are these, the lines?
Those side.
Projectors.
It is called as projectors, or it is called as the line of sight. Okay, it is called as projectors in different textbooks. Okay, they will call projectors or line of sight. Okay, so you can mention here we will define what is line of sight now. Write down. What is line of sight? Write down. Note. It's very important. Note. So how you can define the line of sight? See, write down. It is an imaginary. It is an imaginary ray of light. Okay. It is imaginary a ray of light. Okay. See here. It is an imaginary a ray of light. Okay. Ray of light between an observer's eye and an object. So this is called as line of sight. Okay, the line of sight can be defined as it is an imaginary, imaginary ray of light, because we cannot see, right? Only we can see the shadow. Okay, we cannot see the line which is passing on the object. So they are calling that as imaginary. So an imaginary the ray of light which is passing, okay, from the observer eye to the object. It is called as what? Line of sight, or it is called as projectors. So everyone is clear, right? Anyone has any doubt?
No, sir.
Okay, good.
No, sir.
So be careful. So this is very important. Okay, this concept is very important. Okay, to understand your CAD codes. So if anyone has any doubts, kindly should ask me now itself. So any doubts? So kindly write down everything. Next, we'll move on to the types of projection. Types of projection. Can anyone tell me what are the different types we have?
Single view projection and multi-view projection.
Single view projection. Next is multi-view projection. So we have two types of the projection system. One is,
Single view projection.
mind is here. The projection type we will use because to convert, okay, the 3D into 2D, right? The main purpose why we're using the projection system is to convert 3D to 2D, right? So we'll be having 3D objects. So by using the projection system, so we will see in the form of 2D, right? Students, anyone should respond to the question.
Yes, sir.
Yes, sir. Yes, sir.
Yes,
So that is
sir.
the main. So that is
Yes,
the
sir.
main aim. So that is the main aim. So we'll be having 3D objects. So by using the projection system, okay, projection type, we will convert the 3D into 2D. So that is the main purpose. Now we will go for single view projection. Okay. In single view projection, write down. In single view projection, again you have three types. Write down. I will explain you one by one. Okay. The first type is, write down, prescriptive. Okay, prescriptive projection. Second is oblique. Okay. Wait. Okay. Second type is oblique. Okay. Oblique projection. The third type is, write down, axonometric. Okay, axonometric. So these are the three, okay, different types in single view. Again, in axonometric, you have another three types. Write down. First type is dimetric. First type is dimetric. Second type is trimetric. And third type is isometric. So anyone has any doubt? So anyway, we will discuss one by one, okay? So we will discuss one by one. But in your syllabus, okay, you want to know what is isometric. This is very important. Okay? So this is very important. So other things are concepts. Okay, I will explain you the concept. What is the prescriptive type? What is oblique? What is the meaning of oblique? And in the axonometric, again, I will explain you what is diametric, what is trimetric, and what is isometric. But in your syllabus, isometric you have. So everyone is clear?
Yes, sir.
So
Yes,
we'll
sir.
solve
Yes,
the
sir.
problem with the isometric projection. Okay, we'll not solve the prescriptive type or oblique type. Okay, we'll not solve again diametric and trimetric. Only we will solve regarding to the isometric problems. Write down this. Next we will go for the second type, multi-view. Okay, so multi-view. Write down multi-view. Multi-view. You have only one type, that is orthographic projection. Okay, orthographic projection. In orthographic projection also you have four types. Okay, four type. So only but according to the syllabus, okay, we will discuss about the first angle projection and the third angle projection. I will explain all these things, okay, in today's class. So first angle projection. So everywhere you should mention the projection is very important. First angle projection and the second angle projection. Sorry, third angle projection. Again, you have the second and fourth angle. I'll explain you all those things. In multi-view, okay, it is called as orthographic projection. Okay, in multi-view, we will discuss orthographic projection. Okay, we'll discuss orthographic the projection. In this, we'll discuss the first angle, second angle, third angle, and fourth angle. So you have four angle projection system. Okay, we'll discuss one by one. So now we will go for the first. Okay, write down. Write down. One. Okay. In single view projection system. Okay. So we'll go for first type. Write down. Prescriptive projection. Prescriptive projection system. Okay. So write down the definition. Okay, then I will explain the concept. Write down the definition. The projection.
Excuse me, sir.
Tell me. Any
So
doubts?
this is perpetuative or perspective?
Yes, this is regarding to the first one, A, the first type. In single view projection, so we discussing the first type. Okay, that is prescriptive projection.
Okay, sir. Thank you.
Write down the projection obtained. First, write down the definition. Okay, then I'll explain you the concept. Okay, the projection obtained on a plane. Okay, on a plane, or you can say reference plane. See, both are same. In different textbook, they will mention differently. Reference plane or plane. So be careful. Okay. The projection obtained on the plane. See, plane means what? Is right? The screen is nothing but the plane. So be careful. Okay, this is nothing but the plane. It is called as reference plane or is called as plane. Okay.
Yes, sir.
The projection obtained on the plane. Okay. Comma. When the projectors, or it is called as what? Line
Observers.
of sight.
Line of sight.
Okay, both are same. So I'm mentioning here both. Okay. So when the projectors or line of sight converge to a point, okay, is called as prescriptive projection. Okay, this is the definition for your wait. So this is the definition. Okay. So what is the meaning? See, it's very simple. Okay. So write down this sketch. If this is a screen, or if this is the plane, okay, this is the plane, reference plane. Sorry, this is the reference plane. Okay, if this is the object, okay, this is the object. So you may take the ball. Okay, this is the object, and this is the observer. Okay, so observer is here, or you can see the light of source. Okay, observer is here. Okay, so when I'm saying, see, when an observer is seeing the ball, okay, and if you want to see the projection, okay, or plane of projection, okay, see here, when the light of sight, okay, which is passing from the object, okay, if it is converging at a point, so this indicates here this is object, and then the line of sight is converging at a point with the observer, so this is called as the prescriptive projection. So everyone is understood, right? So see here, so when the projection is falling on the plane, it will be like this, right? So right, students, so it is here, it is much bigger than your object. So right, students, hello students, can you hear me?
Sir, can you tell once again perspective of projection?
Okay, see here, this is called as line of sight. Always you should remember this is called as projector or line of sight, See here, if the line of sight is passing from a point, okay, this is called as converge. Okay, see here, according to the definition, see the projection obtained on this reference plane, okay, this is called as the projection, or it is called as plane of projection. Projection which is falling on this screen, right, or plane.
Yes, sir.
Okay. So according to the definition, what is telling, when the projectors or line of sight converge to a point, see here, when the projectors or line of sight converge at a point, see, when with respect to the observer, okay, it should be fixed. So the line of sight, okay, should converge at a point. So this is called as prescriptive. Always you should remember in the prescriptive projection, always the projection which is falling on the screen or plane will be much bigger than the original size of the object. Okay, so this is called as, see, the true diameter. See example, it is called as true diameter. Okay, of the ball may be around 20 mm, example, and if you see the view, this is called as view, which is falling on the plane. Okay, the view diameter will be much bigger than your object, so it may be 30 mm. Okay, in the prescriptive projection. So everyone is clear? Because the light which is coming, okay, is the light which is coming from the light source, okay, it is coming at the same point. See, at the same point the light source will fall on the object, then the object, the projectors will fall on the plane. So if you draw the if you draw the view at the, what you can say, at the plane, so the diameter will be much bigger than your original diameter. So this is called as prescriptive projection. So anyone has any doubt in this? Anyone has any doubt?
No, sir.
So always you should remember converge and diverge. Okay, I'll write here. Convergence, divergence. Okay. See, when you use the so these are, if you assume these are lens, okay, lens, okay, this is called convex lens. This is called as concave lens. Okay, so when a light source is example, okay, if the light source is falling on the convex lens, assume, okay, light source is falling, so at the end, okay, at some distance it will converge at a point. So this is called as convergence. So divergence means, so when a light source is falling, example, assume the line of sight is falling on the lens, so then, okay, the projectors will diverge like this. So this is called as divergence. So everyone is clear?
Yes, sir.
Yes, sir.
So according to the definition, he has mentioned convergence or converge. See, converge is nothing but the light source, okay, will start with respect to the convergence. Okay, so when the light will fall on the object, okay, from the same point, okay, then okay, the image or the view which you can see in this screen or plane will be much bigger than your object. So this type is called as the prescriptive projection. So everyone is clear with this? If you have doubts, okay, immediately you should ask me.
Sir,
So these
once
are called as
again,
objects.
divergence.
Yeah. Anyone has any doubt?
Once again, sir, conversion and diversion once again.
Okay. So here, if so, there are two types of lenses. One is converse lens, convex lens and concave lens. So there are two types of lenses: convex lens and concave lens. Okay, if you keep the convex lens, and if you take the light source here, assume, okay, here you have a light source, okay, light source. So the line of sight, okay, once it falls on the convex lens, so what happens? Okay, the light which is coming out from the convex lens, okay, will try to converge. So this is called as convex lens. Always the convex lens aim is to converge the light, okay, at a point. Likewise, if you take the concave lens, okay, when the line of sight, or you can say the projectors, okay, falls on the concave lens, what happens? The light will diverge, means the light will go outwards. So this is called as inwards. See here, inwards. This is called as outwards. Okay.
Yes, sir.
So this is called as divergence. Divergence means going outside. Converge means what? Coming inside. So everyone is clear? This is called as
Yes, sir.
convex lens. When you use convex lens, it will converge. When you use divergence, okay, it will diverge. The light will, okay, move beyond. Okay, this is the two types. It's very important. Okay, these two are very important. So when I go for orthographic projection, okay, there this concept will come into picture. So right now, so try to understand the prescriptive projection. Okay, so here you should understand. That's here when a line of sight is falling on the object, always you should remember, okay, the true shape will not be appeared in the plane, right? So this is called as apparent. So always you should remember this, apparent diameter. So everyone is clear? Apparent means, okay, change in the diameter. True means actual diameter. So everyone is clear?
Yes, sir.
So anyone has any doubt?
Yes, sir. No, sir.
This is called as plane of projection. Okay, this is called as plane of projection, this diagram. So always you should remember in the prescriptive, okay, the original true diameter will be not falling on the plane of projection. So this is called as prescriptive projection. Next we will go for second type. So which is second type according to our this one? So oblique, right? So
Yes,
we'll
sir.
go for oblique. Write down
Oblique.
second. B, write down oblique projection. Write down the definition of this. First we will write the definition. Okay, then we will try to understand the concept. Write down. In this projection, in this projection, the projection obtained, okay, the projection obtained, okay, on a reference plane. So always you should understand reference plane or plane, okay, is nothing but screen, okay, which the view will be falling on this plane, okay, or VP or HP, vertical plane, or it may be called as horizontal plane. So reference plane where one face of the object is parallel, but the other adjacent face is inclined at an angle of 45° to the plane of projection. So this is called as oblique projection type, okay. I'll explain you now. Kindly write down this. So what is the meaning of this? See, I'll write first I write this sketch, okay, I'll explain you, then I'll write the 3D view. See examples here. This is a sketch which is falling on the reference plane. See, write down, this is a reference plane. Okay, this is a reference plane. Okay. See here, assume this is the image, or this is a picture, okay, which is falling on the reference plane. Okay, reference plane, it is called as what? Plane of projection. This is called as plane of projection. This is called as what? Can anyone tell me which view is this? Anyone?
Front view.
That is called as
Front view.
vertical plane, or it is called as front view, right? Front. Okay, can you see? So this is the object is here. See, object is here. So when I'm seeing the object, so this is what it is falling on the front view. Okay, so this is the diagram, or you can say this is a picture which is falling on front view. So what is the meaning of this? See here, in this projection, okay, the projection obtained on the reference plane. So this is a reference plane where one face of the object is parallel. So that means here, this face, okay, this face you will get the true whatever I can say, true shape. So this will be true shape of the object, true shape of object. So everyone is clear, right? That is called as true shape. Whatever the length and width, okay, it will be same. The length and the width, and the height, example, okay, which is there in an actual object, okay, will be represent, it will be same. So that is the meaning, okay, where one face of the object is parallel. See, parallel means, okay, the shape will be same. So here object will be there, the front face will be parallel to each other. So that is the meaning. Okay. So then you can see, but the other adjacent faces, assume you see these adjacent means adjacent faces, right, students? This side and this side. Anyone should respond.
Yes, sir.
Yes, sir.
So kindly tell yes or no. Okay. If you're not getting, kindly you should intimate immediately. The concepts are very, very important. Okay. So you should understand everything. So here, this is a true face. Okay, which will be falling on the reference plane to the actual object. So if you take, these are the two adjacent faces. Okay. So what is telling is inclined at an angle of 45 degree. So that means here, if you measure this angle, okay, if you measure this angle, the angle, okay, between these two, it will be 45 degree. I think everyone has understood, right?
Yes,
See,
sir.
other angles will be of 45 degree. So this type of projection is called as what? Oblique projection. So everyone is clear?
Sir, can you explain it again?
See, oblique means it's very simple. Okay, if you take an object, okay, if you take an object here, okay, and if you use the reference plane, okay, which is falling on the vertical plane, according to the definition, according to the concept, see the true one of the face, okay, one of the face means if you take, this is the front face, okay, front face, the true so you can see the true what you can say, the dimensions, length and height, but if you see the other adjacent what you can say adjacent faces, okay, it will be inclined to 45 degree. Okay, the angle between, okay, from the x to the another, what you can say, the y, z, assume this is x direction, this is y direction, this is z direction, assume. Okay, so the angle between x and z will be 45 degree. Likewise, if you want to measure this what x and z, again you will get 45 degree. So the adjacent faces angle will be 45 degree. So this is the definition. Okay, what he has explained. So you'll get one of the face will get true what I can say, true shape according to the object, and adjacent faces, okay, the angle will be 45 degree. Wait, I'll explain you within sketch. Okay, see here, I'll explain you within sketch. If this is the so this is the reference plane. Assume, okay, this is the reference plane. So this is the object. You take an object like this. So it's very difficult to write in a 3D view, 3D. So try to understand. Anyway, I will share the PPT and I'll show you. Okay. So if this is object, so kindly try to understand. So so this here, the observer will be there, right? So here observer, object, this is what? Reference plane, right? Right, students?
Yes, sir.
So when an observer is viewing, so see here, the projectors which are falling on the reference plane will be like this. So kindly try to understand. So these are called as what? Students?
Line of sight.
Line of
These are
sight.
called as projectors. Projectors are line of sight.
Line of sight.
Okay, so this is a line of sight. So when you join or to view the picture, okay, which is viewing on the reference plane, it will be like this. Okay. So this is it done. This is it done. So it's very difficult. Okay. So it will be like this. Okay. So according to the definition, what is telling? Okay. So this is the front face, right?
Yes, sir.
See, this is a front face. According to the definition, what is telling? The length. See, this assume this is a length. This is height, right?
Yes, sir.
So when you see from front, okay, which is falling on the reference plane, okay, this length and height will be same. It will be same. The length and height of the object, okay, will be same. That is called as the shape will be same. Okay, in the reference plane, okay, which is falling on the reference plane, the picture which is falling on the reference plane. And other angle, okay, if you want to measure the angle, okay, if you want to measure the angle, see here, if you want to measure this angle, this will be 45 degree. Okay, the angles, okay, which you can measure, it will be 45 degree. The other adjacent faces, see, this is this adjacent, so this is, see, if this is with respect to this, so this is adjacent face 1, this adjacent face 2. Okay, so if you measure the angle, it will be 45 degree. So this is the concept. Okay, always in the oblique projection, okay, if you say the oblique projection, always you should understand the front face which is falling on the reference plane will be same, the length and height will be same, but okay, but the adjacent faces dimensions will be reduced. So here this width, so will be not equal to this always. Okay, so as well as the angle also will changes. I think everyone is clear, right? If this is 90 degree, okay, but when you see in the reference plane, okay, it will be 45 degree. So this is called as oblique the projection system. So everyone is clear?
Yes, sir.
So this
Yes,
these
sir.
are called, see, this is called as parallel. So this line of sight, okay, which is falling on the projection plane, this is called as parallel projectors. See, parallel means parallel and perpendicular. I will explain you now here. Okay, I'll explain you in a simple way. Okay, see, if a line of sight, okay, if it is moving, okay, in the same way, see here. So these are called as parallel. These are called as parallel axis. Okay, with respect to 0 degrees. Here, the inclination is 0 degrees. Here, these are called as parallel. This is called as what? Parallel system. So everyone is clear? So these are called as parallel because the line of sight is moving in the same direction, right? So right, students?
Yes, sir.
Yes, sir.
So when you come for the perpendicular, okay. See, if the light of sight is in this direction, the first light of sight direction is this, and the second light of sight is the direction is this. Example. This is an example. Okay. So this you can see. Okay. This is you have 90 degree. The difference between the light of sight is okay is having with respect to two different directions. So this when 90 degree means comes into picture. So this is called as perpendicular. Perpendicular, okay? Perpendicular. So perpendicular means always okay with respect to this, like this. Okay, when one object or when line of sight, when one line of sight is passing in the straight way, and other is okay, and one is perpendicular. It is called as perpendicular to this. So it is called as okay perpendicular. That is 90 degree. With respect to angle is 90 degree. So when you take a two line of sight, it's passing in the same direction like this. So this is called as parallel. So parallel, perpendicular. So perpendicular 90 degree. Always you should remember. So if you see now, okay, here. So all are parallel, right?
Yes, sir.
See, all are parallel. So there is no perpendicular, right? Here. So right, students?
Yes, sir.
So only is calling parallel projectors because all the line of sight or all the projectors are following straight, okay, in the same, whatever I mentioned here, okay, in the same direction, right? You can see in the sketch. So everyone is clear with this?
Yes, sir.
So anyone has any doubt regarding to the oblique view the projection? So this is very important. This is a concept, okay? Because and we will not solve the problems regarding to this, but okay, but you should understand the concept. Always, okay, the front face, okay, this is called as front face. Front face, okay, the same front face will be falling here, okay, that is same dimensions will be falling here, but the other parallel adjacent faces, okay, the angle will be different and the dimensions will be different. So this is called as oblique view projection system. And we will go last. We'll go for last. Which is the last, students? Write down.
Axonometric.
Yes, sir.
Axonometric. Write down. Axonometric. So first, see, today also I will teach you the theory first, the concept. Okay, then we will go. Then we can solve the problems. Axonometric projection.
Excuse me, sir.
Yeah, tell me.
So can you show the last diagram once more, please?
Okay, wait. Yes. So any doubt? You have any doubt?
No, sir.
Oh, you're writing, ah?
Yes, sir.
Okay. So complete, students, you can complete. I will give time, 2 minutes time. So kindly complete fast. Then I will go for the next topic. So complete, students, I can move forward.
Yes, sir.
Okay.
Yes, sir.
Okay. So anyone has any doubts, kindly you should ask me. If anyone has any doubt, kindly you can ask me. Okay, I'll give time for you. I'll give 1 minute time. So kindly ask me if you have any doubts regarding whatever I taught you now. So anyone has any doubt? No doubts, I can move forward, students.
Yes, sir.
Yes, sir.
Write down the axonometric projection. We'll go for next topic, axonometric projection. Write down the definition. When projection lines, or you can say the projector, okay, or projection lines projection lines, or it is called as projectors, are not making 90-degree angle with any principal axis. Principal axis, okay, that is PLE, not PAL, okay, principal axis. is called as axonometric projection. So what is the meaning of this? Okay, we'll see. We'll see what is the meaning of this. Can anyone describe, so what is the meaning of this? See, principal axis is nothing but your XYZ. Okay. So as I told you, this X, this Y, Z, right, students? You have 3 axes. So these are called as principal axis. All XYZ, X, Y, Z. Okay. What is the meaning of these students?
So like a shadow, not like the light source is at a different angle and the line of projection is at a different angle.
Okay. So according to the definition, what it's telling, the lines or projectors, it should not be 90 degree like this. With any XEX, say this is 90 degree, right? With respect to Y, with respect to the Y direction, Y axis, right? This is 90 degree, right? This is 90 degree, right, students?
Yes, sir.
Yes, sir.
So when you take this as X, so this will be 90 degree with respect to X axis, right? Similar way, okay, if with respect to Z also, if you want to represent the Z axis like this, so this is Z axis. So what is mentioning, okay, with respect to Z or with respect to X or with respect to Y, the projectors, okay, should not follow 90 degree. So this is called as axonometric projection. So everyone is clear?
Yes, sir.
So axonometric means, okay, the projectors, okay, which see if this is object, examples here, if this is object, okay. According to the definition, what is saying, so what is explaining means, you have the observer here, okay, the line of sight should not follow straight path. So this is 90 degree, right? Right, students?
Yes, sir.
So this is not an axonometric projection. Okay, it should not represent the 90 degree. So I will explain you this case now. So this is not an axonometric projection. So write down the first type, trimetric. In here, so there are 3 types, right? Can anyone mention what are the different types in the axonometric the projection?
Trimetric,
Diametric.
diametric, isometric.
Good. Write down the first type. That's trimetric. Shall I write down? Assume this is a cube, okay? So I'm taking a cube. Okay. So this is the view, okay, which we can see in the what you can say in the plane, okay, in the plane of projection. So assume this as A, B, C, D. Okay, these are A, B, C, D. A point, B point, C point, and D point. So this is like a front view. Okay, assume this is like a front view. So this indicates, wait, I'll show you. See here, I'm taking a cube and viewing like this. See here, this is a cube. Okay, it is like this. So everyone is clear like this. I'm keeping like this. So everyone is clear, right?
Yes,
I'll show
sir.
you from, I'll show you from front view it. See, this is a cube. Okay. So see the definition is it should be not been the projectors which are taking with respect to the object. Okay, it should not be 90 degree. So that is the definition. So what I'm making, so I'm keeping the object like this. Means this is the what you can say, the view which is coming on the which will be coming on the plane of projection. So see, this is A. Okay, this is A. Okay, this is A, and B, C, and D. Okay. So this is called as the axonometric projection. Okay, and here in the axonometric projection, okay, we will see only one view. Once I incline like this, see all the 3 dimensions you can see, right? X, Y, Z. Here.
Yes,
So right,
yes,
students,
sir.
you can see what is the X, what is the Y, and what is the Z. Right?
Yes, sir.
Yes, sir.
Yes, sir.
It is not like the previous cases. Okay, so it is totally different. In a single view, okay, this and in the axonometric projection, in a single view we can see all the 3 dimensions. So that is the one, okay, what we can analyze in the axonometric projection. Okay, it is not like the previous what we discussed. Okay, the different types of projection. Here be careful. Here be careful. One, what is mentioning, this should assume alpha, the angle, okay, from the reference line to the AC, as well as from reference line to the AB. Okay, always note, always in the trimetric, the trimetric projection, okay, always alpha will not be equal to beta. So what is the meaning of this? Can anyone means tell me? What is the meaning of this? Alpha will not be equal to beta.
The angles are not equal.
Yes, this indicates angles are not equal always. Okay, so that indicates if you keep if you're inclining this cube, okay, in this way, the alpha will not be equal to beta. Okay, as well as write down AB distance will be not equal to BC, and BC distance will not be equal to AD. So this is called as trimetric projection. Okay, trimetric projection means, so take a cube, see here. So this is condition. Okay, this is a condition. So if you take a cube, okay, and if you incline like this, okay, and if this condition occurs, see if you incline like this, so there will be a reference plane will be there, right? Reference line will be there. If alpha is not equal to beta, and AB is not equal to BC, and BC is not equal to AD, then this figure is called as, or the projection which is falling on the what you can say in the reference plane is called as what? Trimetric projection. So everyone is clear?
Yes,
This is the
sir.
first condition. If this condition exists, so this is called as what? Trimetric projection. Similar way, see a similar way, write down. Similar way, we can see for dimetric also. Write down for B, dimetric projection. So these are conditions, okay? These are conditions. If this happens, okay, if this AB is not equal to BC, and BC is not equal to AD, as well as alpha is not equal to B. So if this condition exists, so this is called as what? Trimetric projection. Okay, alpha is not equal to beta, AB is not equal to AC, and AC is not equal to, sorry, this is not A, this is AC, okay? So this is AC. So be careful. AB is not equal to AC and AD. So all the dimensions will be changing. Okay. But in actual, if you take the actual cube, see all the dimensions will be same, right? So right, students?
Yes, sir.
If you take a cube, see always you should remember Okay, all the dimensions will be same. But in this condition, what is mentioning, okay, if you incline this cube, okay, to a certain limit, when alpha is not equal to beta, that is angles are not equal, as well as AB should be not equal to AC, and AC should be not equal to AD. So if this condition exists, it is called as trimetric projection. So write down next. Next we will go for the dimetric. So this is a reference line A, B, C, okay, write down. Okay, so A, B, C, D, alpha, beta. So write a cube. Okay, so write a cube and mention A, B, C, D, alpha, beta. So what is the dimetric? It's very simple. Note, write down note. If alpha will be equal to beta, so what is the meaning of this? What is the meaning of this?
The angles are equal.
The angles are equal, and write down AB will be equal to AC, but not equal to AD. Okay, so this angle, okay, will be same. Sorry, this distance, okay, when you see, okay, in the front view, always it will be same, but this AD will be changing. Here, see here in the trimetric, all the distance varies. Okay, all the distance as well as the angles vary. So let's call it trimetric. When you come for dimetric, the angles will be same. The distance between AB and AC will be same, but AB, AD will not be same. Okay. So everyone is clear? It is called as dimetric projection. So everyone is completed?
So once again, sir, the last part, can you repeat it?
Here, the angles will be same, alpha and beta will be same, right? So that is the first condition. Second condition is AB distance will be similar to AC. So the distance will be same. So when you see, when you incline this, here, when you're inclining this cube, here, try to understand, see, when I'm inclining this cube, okay, see like this. So what is the meaning? The angle will be same, okay? The
Yes.
AB, this is called as AB, right? AB and AC, the distance will be same, but AD distance will be vary. Okay, this distance varies. So when
Okay,
you,
sir.
so when you see the dimetric, so
Okay,
alpha
sir.
will be equal to beta, AB will be equal to AC, but not equal to AD. Okay,
Okay.
but when you see the trimetric, alpha will be not equal to beta, it will be like this. Okay, the angle changes, as well as AB will be not equal to AC, and AC will be not equal to AD. Right?
Okay, thank you, sir.
So anyone has any doubt? Okay, this is called as what? Dimetric. So everyone is clear with dimetric?
Yes, sir.
Yes,
I
sir.
can go for the
Yes, sir.
third one, isometric. So this is very important. Okay, this is very, very important for you, because we will solve the problems with respect to isometric. Isometric projection. Okay, write down isometric projection. Reference line A, B, C, okay, then D, okay. So this is called as isometric. So always you should remember, alpha and beta. Okay, this angle, the distance. Don't say note, you can write down note 1. Alpha will be equal to beta. Okay, you can write down that is 30 degree. Okay, so always isometric, the angle will be 30 degree. Here alpha and beta will be what? How much? 30 degree. So everyone is clear? So that
Yes, sir.
indicates, say if you're inclining the
Sir.
cube, if you incline this cube, the angle, okay, from the reference plane is should be 30 degree. Okay, if you incline like this cube, okay, if you take reference plane, the angle should be how much? 30 degree from each sides. Okay, and write down AB should be equal to AC and AC should be equal to AD. See all the dimensions, okay, from AB to AC and AD, okay, it will be similar, it will be same. So this type of the projection is called as what? Isometric projection. So everyone is clear with this?
Yes, sir.
Write down
Yes, sir.
isometric projection. I'll write the definition because this is very important. So write down isometric projection definition. This projection is a type of pictorial projection. See, pictorial indicates here. This what is the meaning of pictorial? Can anyone say, tell me what is the meaning of pictorial?
Representation of a picture.
What, ma?
Representation of a picture.
Representation of a picture. Okay, and the main thing here is, okay, pictorial represent
2D, sir.
you should see all the length, okay, then width, or you can say the breadth, height and height of an object. Okay, so if you're viewing or if you're seeing in the projection plane, in the projection in the projection, okay, that is plane of projection, you should see all the 3 dimensions: length, then this is called as width or breadth, whatever it may be, width or breadth, okay, and height. If you see here, if you see the sketch, so you can see the length, right? See length, height, then width. Right, students, you can see all the 3, right? All the 3 dimensions.
Yes, sir.
So this is called as pictorial projection. So be careful. Pictorial means the projection in which the length, width and height of an object is shown in one view. So this is called as one view. Okay, in one view we can see all the length, width and height. So it is called as what? Pictorial projection. So everyone is clear?
Yes, sir.
So in a one view, okay, you should see all the 3 dimensions. So that is called as pictorial projection. Okay, so write down. This projection is a type of pictorial projection. Okay, comma. The projection obtained on a plane, on a reference plane, or plane. Okay, here 3 major dimensions of a solid are not only shown in one view, and also their actual sizes can be measured it can be measured directly from it. See, only see, we can see the three views, that is your length, height and width, and also we can measure that, and also we can means measure, we can calculate the dimensions of length, height, width, okay, in a single view. Okay, students, so that is the meaning. See, one view, we can see the one view, it is not only showing the one view, and we can measure the actual sizes. Okay, that is your length, height and width. So everyone is clear?
Yes, sir.
Okay,
Yes, sir.
write down in isometric projection. In isometric projection, okay, isometric projection. Projectors, okay, the projectors are parallel but inclined at an angle of 30 degree to the plane of projection. So it is parallel. See the line of sight which is falling on the projectors are parallel. Okay, but it is inclined, right? Here, so this is nothing but the line of sight, okay, which will be falling on the projectors. So it will be parallel, but in the form of angle 30 degree. See, wherever you measure, okay, the angle will be 30 degree. Okay, students. So anyone has any doubt in this? So this is very important. 30 degree is very, very important. So you want to incline the cubes here. You want to incline the cube. If you take a cube, or if you take any object here, we should incline the object. If this is a front view, okay, if this is a front view, okay, I should incline this object or this cube, okay, where it looks alpha will be equal to beta, as well as AB should be equal to BC and BC should be equal to CD. Sorry, AD, right? AB,
Yes, sir.
AB should be equal to AC and AD. Here, the line of sight which is falling on the projectors will be parallel like this here. Here. So when you incline like this, okay, the line of sight will be like this, parallel. See, this is the line of sight. Okay, the line of sight will be passing like this. Okay, like this. It will be parallel, but it will be inclined. With respect to 30 degree. So that is what is telling. Inclination will be 30 degree, right? So if you see like this, okay, the line of sight will be passing will be 30 degree like this. Okay. So this is called as isometric projection. So in isometric projection, so be careful. Okay, we can see all the three dimensions. Okay, and all the three views, as well as we can measure the actual sizes in a single view. So this is called a single view. So here there is no like a top view, side view. Okay, nothing is there. Only the front. By analyzing the front view only, we can find, or we can see all the three dimensions, as well as we can find the dimensions also. We can see the dimensions also. So this is called as isometric projection. So anyone has any doubt till this?
No,
No, sir.
So I'll give you 2 minutes time. So kindly try to analyze whatever I taught you now. And if you have doubts, okay, you can ask me. And within next 5 minutes, okay, I will start the multi-view. That is multi-view projection system. So try to analyze this. Okay, all the thing, whatever I taught you now. Okay, regarding to the projection single view. Okay, single view, that is prescriptive projection, oblique view projection, axonometric, in axonometric, trimetric, and isometric. So from past 1 hour, I taught you this. Kindly, okay, see the previous pages, and if you get doubts, okay, you can ask me. I'll give 5 minutes time for you. Okay, next we'll go for multi-view projection. So multi-view projection is very important. So kindly, I will give 2 minutes time. So kindly try to analyze, okay, this. Then we will go for the orthographic projection system. That is your multi-view. In another 1 hour, I will teach you the multi-view projection system. So it is very, very important. Okay. So in your syllabus, okay, you want to study the multi-view only, orthographic projection only you will study. Okay, from if you take from points, planes, okay, points, lines, planes, solids, every problem is regarding to your orthographic projection system. So I will teach you what is meant by orthographic. So everything I will teach you now. So kindly okay, to turn over the pages, the previous pages, and try to analyze. Okay, and if you get doubts, kindly unmute yourself and you should ask me. So anyone has any doubts? Students, can you hear me?
Yes, sir. Yes, sir.
Okay, thank you.
Yes,
So
sir.
anyone has any doubt?
No, sir.
Okay. Kindly look for another 5 minutes. Okay, 2 minutes. Around 2 minutes. I'll give you 2 minutes. Okay, and I will come back.
Okay.
Students, can you see the screen?
Yes,
Yes,
sir.
sir.
Okay. So if you do not have any doubts, okay, I'll move on to the next topic, that is multi-view. So today I will try to finish this, and I will give some assignment for you, okay, regarding to this. So kindly you should try to okay, you should try to understand each and everything, and if you have doubts, immediately you should unmute yourself and you should ask me. Okay. The video is clear, right, students?
Yes, sir.
Okay.
Yes, sir.
Write down. Next is we can go for multi-view. Write down multi-view. Multi-view projection. Get down.
So the screen is not visible.
Huh? Screen is not visible. Okay, wait. I think now it's visible, right?
Yes, sir.
Okay. Is the video clarity is clear?
Yes, sir.
Yes.
Okay. Write down. So I think we finished till now till single view projection. So now we'll go for the multi-view with the projection systems. Write down in multi-view. First, we will try to understand what is orthographic projection. Write down. First, we will try to understand what is orthographic projection system. Write down the definition. The definition. If the rays, write down. If the rays of light, okay, or it is called as projectors, or it is called as the line of sight, right? Students, can you hear me?
Yes, sir.
Okay, you should tell yes or no.
Yes, sir.
Yes,
Yes.
sir.
Okay. If the rays of light, or it is called as the projectors, or it is called as line of sight, or it is called as projection lines, everything are same. Okay, or it's called as the projection lines. So in different textbook, okay, they will mention in different names, but all are same. The projection lines from the object, from the object remains parallel to each other, and perpendicular. See, parallel means like this. Okay. Perpendicular means like this. Perpendicular to the plane of projection. Projection is called as orthographic projection. Okay, so everyone has written the definition.
Yes, sir.
2 minutes. Wait.
So definition is defined as if the ray of light, or it is called as line of sight, or it is called as projectors, or it is called as projection line. Everything is same. Okay, the concept is same. If the rays of light, okay, or projection lines from the object, okay, be careful, from the object remains parallel, okay, to each other, okay, and perpendicular to the plane of projection is called as orthographic projection. So I will tell you the concept. Okay, what does it mean by that? What is the meaning of that? So everything is completed. I can move to the next page.
Yes, sir.
Yes, sir.
Completed.
Students, I can move for next page.
Yes, sir.
Okay, thank you. Here. So this is the plane of the, or you can say the screen, or you can say the reference plane. Okay, this is called as a reference plane. Okay. reference plane. Okay, if you assume, okay, you have the object like this. Okay, rectangular plate. Okay, so you can say this object. So this is the light source. Light source. And here, okay, there is observer. Okay, it's observer. So when a light source falls on the object, so what happens? These are called as the ray of light. Okay, so what happens, students? Students, can you hear me? Hello.
Yes, sir.
Convergence
Yes, sir.
takes place.
Okay.
Yes, sir.
So this is a reference plane, object, light source, observer. Okay. So when this falls, it will be like this. So this is the front view of the object, right? So this is called as plane of projection. So any doubt, students? Any doubt?
So your camera got on.
No, sir.
So it's clear, right? The
Yes,
screen
sir.
is,
Clear, sir.
the
Clear,
video is
sir.
clear, right?
Yes, sir.
Okay, okay. See, so see what type of the projection is this? Can anyone tell me? What type of projection is this?
Orthographic projection.
Students, listen carefully. What type of projection is this? See, this is the original actual size of the screen. Sorry, of the actual size of the object. So when you're viewing in the reference plane, it is the size of the object is bigger than the original size is right.
Perspective projection.
Perspective
Perspective
projection.
projection.
This is called as prescriptive projection. So this was the answer I was looking. Now what is orthographic? So this is called as prescriptive projection, right? See, whenever a light source is falling on the object, okay, object. See what happens. The object. This is called as projectors. So you kindly listen carefully, students, because I cannot repeat number of times. See, today almost it's around 3 o'clock. So almost 1 hour 15 minutes got over. Okay, still I'm in basics. I'm going slowly. So kindly listen carefully and think. Whenever you are answering, kindly think and answer. Okay. So if you see, these are called as projectors. What is called as line of sight. See, you can see the projectors which are falling on the reference plane. Okay, this is the actual size of the object, and this is bigger than that. So this type is called as prescriptive. Now we will see what is orthographic. So orthographic is very simple. So always you can mention A, B, C, D. Okay, A, B, C, D. Always you can call this as A1, B1, C1, D1. Here always your A1, B1 will be not equal to AB, as well as your A1, D1 will be not equal to AD, right? Always the length as well as the height will changes, okay, in the prescriptive projection. But when you come for the orthographic projection, write down. So this is your prescriptive projection. What we should do for orthographic? You write down. Same sketch. Okay, same sketch. I'm writing this the same sketch. So this is object, right? Right, this is the object. So according to the definition, what is telling? See, kindly refer the definition. See here, if the rays of light, okay, from the object remains parallel. So what is the meaning of that? Your projector should be parallel to each other, right?
Yes, sir.
Okay. So always you should remember, see, object remains parallel to each other means what? So your line of sight or projector should be parallel to each other and perpendicular to the plane of projection. So it should be parallel, the projector should be parallel, and from the plane of the projection it should be perpendicular, that is 90 degree, right? So that is what it is telling. So if you see here, see the line of sight is parallel here. Students, you should reply. So this is parallel or not? The lines are
Yes,
parallel
sir.
here.
Yes, sir.
The line of sight
Yes,
is
sir.
parallel or not?
Yes, sir. It's parallel, sir.
It's parallel. How it's parallel, man? See, parallel means I told you this is a parallel. How much times I should tell you? So this is parallel to each other. So this is parallel to each other.
No, sir.
So it should go straight, right? So here you can see it's going with a pretty inclined some angle, right?
Yes, sir.
So it is not parallel. The first concept is what is telling from the object, okay, which the projector is moving, it should be parallel to each other. So that is what it is telling. So for that, what we should do, we should keep a convex lens here. We should keep a convex lens. Okay, before your object, we should keep a convex lens, and then we should place a light source. Okay, light source. Here here observer will be there. Okay, so when a light source is falling on the, first it will fall on the, okay, first it will fall on the convex lens. Okay, then it will try to, okay, move straight. Initially it will try to move straight. Okay, it will fall on the object. Okay, then what happens? Okay, the line, then we can say, okay, it will move straight. You can see here the projectors will move straight like this. Everywhere, okay, everywhere. Okay, first it will follow the straight path. From the rays which are coming outside from the convex lens initially, okay, we'll keep distance will be very less. So directly it will go and it will fall to the object. Okay, then it will follow the straight path. See here, this is 1, 2, okay, then 3, 4. See here, this is the plane of projection, right? This is the plane of projection. Okay, so this is your reference plane. So everyone is clear, right? This is called as projectors, which are falling on the reference plane. If initially we should keep the convex lens here, okay. Due to that, the rays which are falling on the orbit will be straight. Always it will move straight. So these are called as parallel. Okay, parallel to each other. See, one is parallel to each other. The projectors are parallel to each other. Okay, and if you measure, see, if you measure the angle between these two, the projectors and the plane of projection. Okay, if you measure this angle, this will be perpendicular to each other. So everyone is clear with this? So anyone has any doubts? So according to the definition here, remains parallel to each other and perpendicular to the plane of projection. See, it is very important, perpendicular to the plane of projection. So that means the projector which is falling on the in the reference plane, it should be perpendicular, see 90 degree. So this is a line of projectors, and this is the front view, okay, which is falling on the reference plane. So it will be perpendicular. See, wherever you find, okay, it will be perpendicular to each other. Right? Right, students?
Yes.
Yes, sir.
Yes, sir.
Everyone is clear
Sir.
with this?
Yes, sir.
Always here you can find the true length. Okay, so you'll get the true length. So that same length and height. Okay, so same length and height you can find here also in the plane of projection. The length and the height will be same. But when you come for the prescriptive projection, the length and height varies. So that is the difference here. A, B, C, D. Okay, A dash, B dash, C dash, and D dash. Here always you should remember A, B will be equal to A dash, B dash, and C dash and C, D will be equal to C dash and D dash. So this is the concept of your orthographic projection. So anyone has any doubt with this?
No, sir.
So here you should remember the three things. One is the observer. So what are the elements so that are required to find the plane of projection? Students kindly should respond to the question. So what are the things you required? The elements. One is observer.
Light source.
Convex lens.
Then
Object.
object. Then
Screen.
screen, or it is called as reference
Screen.
plane.
Yep.
Okay, always don't mention screen. Okay, you should mention reference plane. Okay, screen is okay in technical term or technical. Okay, in CAD codes we'll call that as the reference plane, not screen. Always you should mention as reference plane. Okay, be careful here. Observer, light source, convex lens, object, then reference plane. Okay, these are the important things, okay, which are required, okay, to analyze the orthographic projection system. So everyone is clear? So anyone has any doubt? So kindly you can ask me now.
Sir, what is that C dash and D dash?
So this is see once the projection is followed on the reference plane. So this is C, right? This is the actual, what you can say, this is the object. I'm mentioning A, B, C, D, right?
Yes, sir.
Okay, the image which is falling on the reference plane. Okay, so I'm calling as A dash, B dash, okay, C, then C dash, D dash. Okay, then I will try to measure what is AB. This is AB length, and this is the A dash, B dash length. Okay, in orthographic projection always the length will be same. Okay, if you measure in orthographic projection, that AB will be equal to always A dash, B dash. So that is the concept here. So for that sake only we are using the orthographic projection. You will get the same true length here. Okay. See, AB will be equal to A dash, B dash. CD will be equal to C dash and D dash. But when you come for the prescriptive the projection, always it varies. Okay, your AB, okay, will not be equal to A dash, B dash. Your CD or AD, okay, will be not equal to each other. Okay, in the prescriptive projection systems. It's clear?
Yes, sir.
It's clear, students?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Write down. Next. The next point. Orthographic projection is nothing but conversion of what? 3D object to what, students? What? 3D object to
2D.
yes,
View.
2D views. So it's very, very important. Okay, 3D object is converted into 2D views. So this is the 3D object. So we are converting into 2D. That is a length and height, right? This is view. So we are converting 3D object to the 2D views. Okay. Write down next point. The dimension of the image, or you can say the plane of projection. Okay, this is called as your plane of projection. Okay, this is nothing but a plane of projection or image, okay, which is falling on the reference plane. The dimensions of the image or plane of projection having same similarity, okay, same similarity with the original object. That means your length and width will be same. Always your dimensions will be same. So that is the meaning. Okay. So anyone has any doubt till this?
No, sir.
So did you understand what is the difference between your means your prescriptive projection and the orthographic projection?
Yes, sir.
Always the projectors will be parallel to each other, and the projectors which are falling on the projection in the reference plane, that is your plane of projection, it will be perpendicular. Okay, it will be perpendicular to each other. That is 90 degree. Always see 90 wherever you measure. Okay, you'll get the same angle, 90 degree. But the projectors are parallel to each other. Okay, and the angle between the plane of projection and the projectors will be 90 degree. So this is the second point. And to obtain this, we should place the convex lens, okay, in between the object and the light source. So everyone is clear?
Yes, sir.
Yes, sir.
Okay. So if you do not place the lens, what happens? You'll get the what type of projection you get?
Perspective.
You'll get the means prescriptive projection. You'll get this type. Next, we'll go for next topic. Write down in the orthographic the projection itself. Write down quadrant systems. Quadrant system. Okay, this comes under your multi-degree. The projection. Okay, in your orthographic projection itself. Write down. So write down the similar way. Write down like this. See students, kindly write down in the similar way. Then you will feel easy. Okay. Write a straight line in the vertical direction. Okay, and horizontal direction. So everyone is clear? Write a vertical direction and horizontal direction. Okay, with respect to inclined. The similar way, draw a vertical line. Okay, and join these two. And join these 2 points. Okay.
Sir, screen not visible.
I think screen is visible, right, students?
Visible.
Okay, thank you. Now join these 2 lines. So these 2 points. Okay, so this is called as what?
Reference plane.
Or it is called as vertical plane, right? Reference plane. Initially, till now, we called as that is reference plane. Okay, reference plane or vertical plane. Now, what you will do? Okay, take an inclined line like this here. Take an inclined line. Okay, like this, and take a perpendicular to this. Okay, perpendicular line. In both the directions, see both the ways, and join between these 2 points. Okay, next here from this point to this point you join. Okay, so this is called as, so this is called as xy. From this point to this point it is called as xy line. So this we will call as reference line. Okay, in our term, in our CAD term, we will call this as reference line. Be careful. Reference plane is different and reference line is different. So reference line is nothing but xy. Okay, the line, the connection between, okay, from this point to this point is called as reference line. Next here, so this is called as what? Anyone? So this is vertical plane. So what is this? I told you in class, right?
Horizontal.
Yes, this is called as horizontal plane.
Horizontal plane.
Horizontal plane. So this is called as vertical plane. Okay. So write down, everyone should write down this. This is very important. Okay. This is very important. So horizontal plane, vertical plane, this is reference line. Okay.
Yes, sir.
So next here, see what is this? What is this? Student, what is this?
Left side.
Left side. Now it is called as, write down, profile plane. Okay, in technical term, we'll call this as profile planes. Okay, profile plane. So be careful, profile planes. Okay, these two are called as profile planes. Okay, these two are called as profile planes. Okay,
Sir, the screen is bit little bit blur, sir.
now it's okay, now it's fine.
Yes, sir. Now it's
Okay, see profile plane. So these two are called as profile plane. So this is called as vertical plane. This is called as horizontal plane. So everyone is clear with this? So
Yes, sir.
if you understand this,
Yes,
then only I
sir.
can move forward. Okay. See, always see here in the orthographic projection, always you should remember, okay, the observer will be fixed. Okay, the observer will be fixed. Observer position will be fixed. Okay, observer position will be fixed. Okay, so observer will be here. So be careful. Observer position will be fixed. Okay, here there will be two terms. So always you should remember this. Okay. So this side indicates, okay, see this is called as your first quadrant system. Write down first quadrant system. This is called as first quadrant system. Okay, this side. Okay, opposite to this here. Okay, this is called as second quadrant system. So everyone is clear? So anyone has any doubt? So this is your first quadrant system. Okay, this side. And opposite to this, it is called as second quadrant system. Okay. Then down here, So this is called as your third quadrant system or third quadrant projection. Okay, first quadrant the projection, second quadrant the projection, third quadrant the orthographic projection, and here, okay, this is called as fourth quadrant. Okay, fourth quadrant. Okay, fourth quadrant the projection orthographic projection system. Quadrant, okay, quadrant, okay, quadrant. First quadrant, okay, first quadrant system, second quadrant system, third, fourth. So everyone is clear? Anyone has any doubt?
No, sir.
Okay, anyone has any doubt? Okay, see here, this indicates, see, when an object is kept on the first quadrant, examples here, when a ball is kept on the first quadrant system. So now I'm mentioning first quadrant system. So this indicates the observer is here. Okay, this indicates it is with respect to the VP vertical plane. Okay, we should call that as in front of VP. So be careful, in front of vertical plane. Okay, because it is front. Okay, front with respect to the observer, right? So this is a plane. Okay, it is in front of vertical plane, right? Next here, with respect to the horizontal plane, it is above HP. Here, above HP. See, this will be below HP. So this is the horizontal plane. Okay, down it is called as below HP, and up it is called as above HP. So everyone is clear with this? In front of VP. Okay, see, I'm considering a ball. Okay, I've kept in first quadrant system. So if I want to speak with respect to the vertical plane and horizontal plane, so I'm telling in front of VP because, okay, the observer is here, so you can see directly the ball. Okay, so it is called as in front of VP and above HP in the first quadrant. Okay, first quadrant system. When you keep the ball in second quadrant, so what happens? See, I'm keeping the observer is fixed here. That is irrespective of the object. Okay, wherever you want, you can keep the object, but the observer should be fixed. So okay, observer should see from ear itself. Okay, with respect to second quadrant here, again you can tell that with respect to VP, it is called as behind VP. Okay, behind of VP and above HP, because it is above, right? Above HP. So everyone is clear with this? The second quadrant. See, behind of VP and above HP. Okay, because the ball is in the second quadrant, so it is called as above. So let's see, when you take the ball and when you keep in the third quadrant, so what happens? Can anyone tell me now? Can anyone tell me now? So what you should mention with respect to VP and HP?
Behind profile plane and below HP.
Behind of VP, that is your, because of, okay, the ball is behind VP and below HP, right? Because the ball is below, okay, below the observer and behind, okay, behind the VP. So behind of VP and below HP in the third quadrant. But when you keep the ball in fourth quadrant, so what happens? See here, it is in front of VP again, because it is in front, because the observer can see ball easily. So it is called as in front of VP, and you can say below HP, right? So right, students, so anyone has any doubt till this? Kindly, if you have doubts, you should ask me, students. So kindly say this, and if you have doubts, you ask me. This is very important. So this is very important, students. Okay. Understanding is this is very important. In front of VP, behind VP, okay, above HP, below HP. Okay, this is very important. So anyone has any doubt?
No, sir.
Okay. See, always.
No, sir.
So I will write here. I'll write the first quadrant. See, first I'll write in the form of, see, when you see like this, when you see like a front view, okay, like, so you can see when you convert this into 2D, how it looks. It will look like a plus mark. Okay, so this is VP, this is HP, right? Right. Vertical plane on horizontal plane. So this is your first quadrant. First quadrant. First quadrant. This is second quadrant. This is third quadrant. And this is fourth quadrant system, right? So, right, students? Right? If anyone has any doubt till this? So anyone has any doubt, kindly you should ask me immediately. Say first, second, third, fourth. First, second, third, fourth. Okay. Now I will explain you by each individual quadrant. Write down. First quadrant system. First quadrant system, or first quadrant cartographic projection system. See here. Okay. Here there's this object here. Ball, you assume that there's a ball. Here there's a observer. Observer. Okay. So here, can anyone tell me what is this? This is VP plane, vertical plane. This is horizontal plane, right? Can anyone tell me? So with respect to VP, so in what way we can mention this? Anyone fast? Kindly see this sketch and kindly represent this. So this is called
Above
what?
HP.
Above HP. And what is this? In front of VP. So when I'm seeing the ball, so what happens? Okay, the image, or you can say the projectors, okay, will be falling on VP plane, vertical plane or the reference plane. So this is called as front view, right? Right, students? So this is called as the projectors or the line of sight. Similar way, when I see from top, okay, the projectors will be falling on HP plane and it will look like this. So this is called as the top view. Top view, this is called as front view, right?
Yes, sir.
Front view and top view. So you should represent always, if you see in front of VP and above HP. So which quadrant is this?
First quadrant.
This is called as first quadrant. Always you should analyze, okay? When I mentioned that, okay, a ball okay, is okay, a ball is a ball dimension is from in front of VP is 20 mm and above HP is 30 mm. So this is called as first quadrant system. So always you should remember first quadrant represent, okay, in front of VP and above HP, right?
Yes, sir.
Okay, similar way, if you go for second quadrant system, okay. So this represent, I'll write in the form of 2D view. So this is your VP vertical plane. This is your horizontal plane. So if you keep a ball here, okay, this represent, okay, I'll write here, sorry, I'll write here. First quadrant represent in front of VP and above HP, right? No, right. In a similar way, here, this is called as behind of VP and above HP, right? So this is called as second quadrant system, second quadrant orthographic projection system. Okay. If you mention here, second quadrant is nothing but behind of VP and above HP. Everyone is clear with this? Anyone has any doubt? Students, kindly should ask me the doubts if you have, okay? So if you have doubts, kindly should ask me immediately. Next, write down for the third quadrant system. For the third quadrant system. See, it is like this. The 2D view is like this. If I keep a ball here, so this indicates, so this is VP, this is HP, right? Horizontal plane, vertical plane. So this is what? This also it is behind of VP and what, students?
Below HP.
And it's called as below HP. So here you can mention the third quadrant represent behind of VP and below HP, right? And last quadrant system. And fourth is, write down, fourth quadrant system. Fourth quadrant system. It's like this. This is HP, VP, vertical plane and horizontal plane. So if I keep the ball here, so this indicates, okay, in front of VP and what? In front of VP and below
HP.
HP. So you can write down here, fourth quadrant represent in front of VP, vertical plane and below horizontal plane. So this finishes your fourth quadrant system. So I think by this, today I will stop the class. I think this is more than enough. So tomorrow, I think at Wednesday, I will start the representation of quadrant in the orthographic projection. So that is very, very important. So if I complete this, then we'll go for problems, okay? So I think today, I think I've completed maximum the concepts. So I started with the principle of projections. Okay, then I taught you the types of projection systems, single view and multi-view projection. In single view, okay, that is prescriptive, oblique view, and axonometric projection system. After that, okay, in multi-view projection, orthographic, what is meant by orthographic projection? Okay, how we should draw the orthographic views. Okay, later on, we discussed about the quadratic systems. Okay, 1, 2, 3, 4. Okay, then I discussed, okay, one by one. Okay, see now, kindly you represent here. See what I should mention here. in the first quadrant here, kindly, anyone?
In front of VP, above HP.
Okay, so only I left blank here. So in front of VP, then
Above
then
HP.
above
HP.
HP. Okay. Then what is second quadrant?
Behind VP, above HP.
Behind of VP and later above.
Above HP.
Then what about the third quadrant system?
Behind VP, below HP.
Behind of VP and
Above HP.
Below of HP.
below of
HP.
and last fourth quadrant
In front of VP, below HP.
in front of VP.
Below HP.
Below HP.
Okay. Below HP.
HP.
I think everyone is clear, right, with this, because this is very, very important. If you understand this only, okay, you can solve the problems. Otherwise, it will be difficult. I'm telling you. Okay. So this is very important. You kindly, okay, see the notes once again and analyze. Okay. And if you get doubts, immediately you should ask me. Okay, in the coming class, or you can call me later also. Anyway, I will upload the notes. Okay, whatever I taught you today, I will upload in the Google Classroom. Okay, later I should take the photographs. Later I will upload these notes, whatever I taught you today. So any doubts?
Sir.
Any doubts? You can. Students, can you hear me now? Hello. Hello.
Sir, we can hear you now.
Okay. So don't leave the class. I should take the attendance. Okay. Don't leave the class. I think some 3 to 4 students they left the class. Okay. Kindly intimate them. Okay. I should take the attendance. So I'll give 2 to 3 minutes time. Okay. If you have doubts, okay, you can ask me. So see the notes, and if you want to clarify anything, okay, you can clarify now. Anyway, I will share the I will share the recorded video also. Okay, I recorded the video. Okay, whatever I taught you in today's class, I have recorded everything. So anyway, I will upload this also. Okay.